solve linear systems by substitution. So thus far, we've talked about linear systems, and in a previous video, we showed how you could solve them by graphing. In this video, our objective is we want to solve a system of linear equations in two variables by substitution. So what do we know? Well, we know what a linear system, also called a system of linear equations, is. It is two or more linear equations working together. And they have this curly bracket on the left, and then the equations are off to the right, and these two equations are x plus y equals 7 and x minus y equals -1. This is a system of linear equations in two unknowns in this case. So again, we saw how to solve them by graphing. They can also be solved by substitution. And here's the general idea. Convert the system of two equations in two unknowns into one equation and one unknown by an appropriate substitution. So again, we want to take two equations and two unknowns, and we want to get that down to one equation and one unknown, which is just simple algebra to solve. What are the steps involved? And we'll do a couple of examples so you can see this at work. Solve either of the equations for one variable in terms of the other. Okay, now notice if one of the equations is already a y equals equation or an x equals equation, this is done. So you can skip step one. Step two, now that you have step one done, you can substitute the expression from step one into the other equation. And what this results in is one equation in one unknown. And then of course, that's easy to solve algebraically, step three. Step four says, now we just go backwards. We know what one variable is equal to, so let's take that known and put it back into the other original equation, and then simplify to find the value of the other variable. And then of course, step five, whenever you're dealing with algebraic equations, you should always check your solution. In this case, we want to check our solution in both original equations. Let's take a look. Okay, and I'll see if I can make a note to keep the steps written down for you as I do this. And you can go back and forth. I can go back and forth to what those steps are. I wanted to leave you plenty of space because this can take a little space as you're working your way down. So number one, here's our example one. We want to solve this system using the substitution method. And step one says, solve either equation for one variable in terms of the other. Notice neither equation says y equals or x equals. So we want to set one of them to be equal to x or y. If you look at equation number 2, and I'll label these, if I add 2y to both sides, I have solved equation number 2 for x. So let's do our step. Okay, so our step 1 here, we're going to solve, and I'll abbreviate equation EQU, equation 2 for x, because that's a lot easier than solving equation 1 for x or y. We'll get a fraction. If we solve equation 2 for y, we'll also get a fraction. But if we just add 2y to both sides, x equals is pretty simple. So let's add 2y, and equation number 2 is now x equals 2y minus 3. Again, adding 2y to both sides. Okay, step 2. Substitute what you have here into the other equation. Okay, so step 2. Whoops, let's put a 2 there, not a colon. Okay, we're going to substitute 2y minus 3 in for x into equation number 1. Okay, so equation 1, now that I know that x equals 2y minus 3, I can put 2y minus 3 in for x in equation number 1. So I have 5 times x, which is 2y minus 3. Whoops, I got to get a minus 4 here. Minus 4y is equal to 9. Now notice, as you see in the directions for step 2, I now have one equation in one unknown. In this case, the unknown is y. I can solve that. So step 3, this goes back to some of your pre-algebra days probably. Step 3, solve. Okay, in this case, we're going to solve for y. All right, well, let's distribute. So we have a 10y minus 15 minus 4y is equal to 9. Let's combine like terms. 10y minus 4y is 6y. We'll subtract 15. Let's add 15 to both sides. 6y is equal to 24. Let's divide both sides by 6. And y is 4, or so I think. Okay, so that's step 3, solve for y. Now that we know what y is, we can go back and back substitute, and we can find x. Okay, so step 4, we want to back substitute. Back substitute into either equation 1 or equation 2 to find the other unknown, in this case to find x. Well, let's see, which one will be easier? I'll do this one. Looks like this equation is easier, but it doesn't matter. Okay, let's say equation 2 is the easier of the two to back substitute. So I'll take equation number 2, which is x minus 2y is equal to negative 3. Again, this is equation number 2. We just solved for y and got a 4. So x minus 2 times 4 is equal to negative 3. Well, this is x minus 8 is equal to negative 3. I'll add 8 to both sides, and I have x is equal to 5. Okay, so, all right, proposed, because I haven't checked it yet, proposed solution is the ordered pair x5, y4. That's my proposed solution. I think the ordered pair, the solution is 5, 4. But step 5 says I need to check it. Okay, so, I mean, again, with algebra and equations, it's never the question, am I right? Because we can always check it to see if we're right or not. So here is our check. And we want to check our proposed solution in both equations. So equation 1 is 5x minus 4y is equal to 9. I want to see if this will work. So 5 times 5 minus 4 times 4. Is that equal to 9? Question mark. I don't know the answer. 25 minus 16. Well, that's true. I know that one's right because 9 is equal to 9. And equation number 2 was x minus 2y is equal to negative 3. Again, I think the solution is 5, 4. So I'll put 5 in for x. I'll put 4 in for y. And the question is, do I get negative 3? Well, 5 minus 8 is negative 3. And so we're good. And so the proposed solution of 5, 4 is the solution. I checked it. The solution is 5, 4. And we know that graphically, that means the two lines are separate and they intersect at one point. Okay, let's do one more example. Give me just a moment to get my act together here. Okay, here we go. I think I'm all set. Good. Solve the linear system by substitution. I have a linear system of two unknowns, x's and y. Again, I'm going to label the first one, 3x minus 2y equals negative 5, as equation number 1. And the second equation I'll label with a 2, 4x plus y is equal to 8. Okay, again, I'm looking for something simple. I want to solve one of these two equations for either x or y so that I can then substitute. And it looks like in the second equation, if I solve it for y by just subtracting 4x from both sides, it's a pretty quick move. Okay, so again, step 1, and I'm not going to write the steps down, I'm just going to do it. I'm going to solve equation 2 for y, and I come up with y is equal to negative 4x plus 8. Okay, so that's step 1. Now that I know that y is equal to negative 4x plus 8, I can put negative 4x plus 8 in for y in equation number 1. So step 2, I can rewrite equation 1 as 3x minus 2y. Well, y we just said is negative 4x plus h, so negative 4x plus 8, excuse me. And that's equal to negative 5 if I complete equation 1. Step 3 says, let's solve this. In this case, we're solving it for x. Notice we now have one equation in a single unknown. The unknown is x. So let's solve it. 3x, I'll distribute the negative 2 plus 8x minus 16 is equal to negative 5. 3x and 8x is 11x. Minus 16 is negative 5. Add 16. 11x is 11, I think. Oh, very cool. Divide by 11. And I'm thinking that the x value is 1. The x part of the ordered pair solution is a 1. Step 4 says let's back substitute. Okay, I'm going to use equation 1 this time to see what y comes out to be. And so I have 3x, well, x is 1, so I'll put in 3 times 1 minus 2 times y is equal to negative 5. And I'll solve this for y. Well, 3 times 1 is 3. I'll subtract 3 from both sides. Negative 2y minus 3 is negative 8. And I'll divide both sides by negative 2. And I come up with 4. Okay, so my proposed to-be-checked solution is the 0.14, okay? I think that's the answer. I will let you go through with a check on that one. Of course, we want to check our answer back into the two original equations to see if it's true or not. So that's substitution. You're solving one of the two equations for one of the variables, and then you are substituting the expression into the other equation so that you have one equation in one unknown.